So this is part 2 of the review for our quiz. So looking at number 13, we're going to determine if the following tables represent a linear pattern. And so just to remind you guys, linear patterns show a constant slope. And remember, slopes are made out of x's and y's. So we need to check if the x's and y's have the same patterns within all the numbers. So like all the x's need to be the same pattern and the y's need to be the same pattern throughout all the numbers. So let's look at the pattern. So it goes from -1 to 2, so that it looks like it's increasing by +3. Let's think about it. -1, if I were to go up from -1 to 2, that's -1, +1, and then 2. So in this case, this would be adding by 3. And then from 2 to 4 would be +2. And then 4 to 6 is +2. So that doesn't look quite right to me because it jumped from -1 to 2, so that's adding by 3, and then it added by 2 and 2. So that already breaks the rule, but we can also check the y's, but this already doesn't seem linear. But for the y's, you can see this is adding by 3, 2 to 5 is 3, 5 to 6 is +1, so that's already going haywire. 6 to 9 is adding by 3. So in this case, definitely not linear. There's no consistent pattern. So this is not linear at all. The slope, we can say that the slope is not constant. And then for problem 14, let's take a look again. So 14 goes from, for the x's, 2 to 4. So that's adding by 2. 4 to 6 is adding by 2, and then 6 to 8 is adding by 2. So x's do check out. This here is a consistent pattern. Let's check out for the y. So y goes from 1 to 3, so that's adding by 2. And 3 to 5 is adding by 2, and 5 to 7 is adding by 2. So that's also a consistent pattern. Now let me just say here, it did not have to be that y's had to have been 2's, okay? They didn't have to be the exact, x's and y's don't have to have the exact pattern, but they need to be consistent throughout all their, like the x's should all be the same, and the y should all be the same. So this y could have been having a pattern of adding by 3. But as long as they were consistent throughout, it's still linear. So we can say, yes, this is linear. It is a linear pattern because, oops, I can't spell, because the slope is constant. So something like that. All right, so for this one here, it says state the slope formula. So the slope formula is if you're given 2 points, x1 and x2, you would have a slope formula where you would put the y2 minus y1 over x2 minus x1. So if you're given 2 points, you can use the 2 points and plug it into this formula to get your slope. The slope-intercept form is how we write linear equations typically. We always write like the slope next to the x to the first power and then have our y-intercept at the end of it. Typically that's the case. So just as a reminder, this is the m represents the slope, the b represents the y-intercept. Or where does it hit on the y-axis? So let's practice some of these skill set. So looking at 17 here, it's asking, given these 2 points, determine the slope. So if you have 2 points, that's a perfect time to use the slope formula. So let's go ahead and plug things in. So you can call this x1, y1, your first coordinate point, and then this could be x2 and y2. And so using the slope formula, you would take your y's, y2 and y1, 0 minus 11, plug that in, and then our x's is going to be 5 minus 17, 5 minus 17, which ends up being negative 11 over 5 minus 17, which is, well, 5 minus 17 gives me negative 12. So if that's two negatives, this actually becomes a positive. So it's actually just 11, 12. And I can't reduce that, so my slope here is truly just 11, 12, which is fine. So I'll just leave it as a fraction. Now for 18 here, you are not given two coordinate points. Instead, you're given the graph and you're asked to find the slope as well. And so this is really an estimation of your slope. So depending on which points you pick, it might be a little bit different. But I recommend pick a point that intersects the grid in the intersections. Like this one's a really good point because I think it clearly intersects the grid right there. Whereas like this one would not be a good point because I would have to guess that that would be maybe like 1/2 for the y value. So negative 2 1/2 would be really hard to use. So I wouldn't use that one. But like I might use maybe this one as the next point because it intersects. So if I were to do that, it looks like it goes down 1, negative 1, and over 2. So plus 2 for the run. So remember, slope is also rise over run. So I can also say that my rise here is negative 1 because you're going down, which makes sense because in this case, this line is going this way rather than this way, which is positive. So this is a negative slope. And then I went over 2, so that's my run. So my slope here is negative 1/2. And let's just see if this pattern follows. But notice that if I were to go down 1 over 2, I also again hit it at an intersection. Go down 1 over 2 and I hit it at another intersection. So this is a great estimation of the slope. All right, let's get into question 19. So in these three problems, you're going to be writing your equation in slope-intercept form. So that's that y equals mx plus b format. And so to do this, we need two main ingredients. You need the slope and the intercept. And so sometimes you might be given one piece, but not the other. So like this one here, you're given the slope. And so you already have m. So this is my m. And it says it needs to pass through these points 1 and 5. And so these are coordinate points. So they represent x's and y values. So that means like we have the slope, we have x's and y, we don't have the intercept. And please don't use this 5 as the intercept because that y is not the intercept. Remember, y-intercepts always have a 0 for x, and that is definitely not the case here. This x is a 1. So in order to find the y-intercept, you have to solve for it. So you'll set it up. Like with this equation, you know what the y is. So I'm going to plug in y, which is a 5. M here is a 3. My x here is a 1. And that leaves me with a b to solve for. So I'm going to try to solve for b and then plug in the slope and the y-intercept. So if I multiply this out, this would be 3 times 1, which is 3. Subtract over the 3. So this would end up being 2 equals b. And so b is my y-intercept. But don't stop here. Remember, we need to write this equation. So I need to fill in my m and my b. So this is going to be y equals 3x. That's my slope. 3 is my slope. And then 2 here is my y-intercept. And that is my actual equation, which I should be writing over here, actually. My bad. Okay, so that's my equation. Let's try a trickier one, like where they will ask you for perpendicular and parallel lines. So like if you want something that's perpendicular, remember perpendicular lines are opposite signs and they also are reciprocal. That's really important. So reciprocal means like it's basically the fraction, but it's flipped. So if your slope for this one here, you can see the slope here is negative 2. But if you want the perpendicular to that slope, that means you need a positive number. And think of this as negative 2 over 1. You can always put a number over 1. If you were to take the reciprocal of that, that would need to be 1 over 2. So you flip that fraction, so it becomes 1 over 2, and it needs to be a positive. So here's the slope that I need. And then this is the points that I need to pass it through. So that's my x and y values that I need. So I'm going to start setting things up. Again, I'm going to have to solve for my y-intercept because they don't give it to me. But they do give me the slope and they do give me the coordinates. So this is going to be y equals, let's see, my slope here is 1/2. So I'm going to plug in my y, which is 3, and I'm going to plug in my x. So my y here is 3. My x here is 4. I'm going to solve for b. Zoom that in. So if I multiply 4 with 1/2, think of 4 as being over 1. You can always put any number over 1. So 1 times 4 is 4. 2 times 1 is 2. And if you reduce 4 over 2, if you just take 4 and divide it by 2, you just get 2. So this is going to be 3 equals 2 plus b. And so then I would just subtract over the 2. And so my b equals 3 minus 2, which is 1. So my b here is 1. That's only my y-intercept, so I need to take my 1 now, plug it in for b. So this is going to be y equals 1/2 x plus 1. And so that is my equation. And I'll go ahead and write that in the line here for us, 1/2 x plus 1. Alrighty. So moving on to the next problem, very similar to this one here, but this one's asking for parallel lines. And so anytime two lines are parallel, that means the slope is the same. So same slope, which makes our life a little bit easier. So I'm going to take that 3 and use it for our new equation, but it needs to pass through these points. So those are your x and y. So again, you're going to plug in what you know. You know the slope. You don't know what b is, but you know what your x and y's are that you can plug in to solve for b. So your y here is 1. Your x here is -3. And so solving this out, this becomes -9. I'm going to add over 9. And so 1 plus 9 is 10. So b is 10. And so we have, in this equation, let's go back to our original equation, our slope has to be a 3 because it's parallel, and our b here is actually 10. So this is going to be y equals 3x plus 10 as our equation. So you can start seeing the pattern here that in order to make a linear equation, you need the slope. And so if it's perpendicular, you got to switch it to being opposite and reciprocal. If it's parallel, just steal the same slope. Now, oftentimes you need a y-intercept and they don't give it to you, so you have to solve it by plugging in the x's and y's that you're given, or the coordinate points that you're given. All right, let's head into our final two problems here, talking about looking at slope-intercept equations, being able to graph them, and then stating the slope and the intercepts here. So first off, let's identify the slope. That's the easiest here. So my slope here looks like it is a 2. So just put 2 here. And then my y-intercept, I can already tell right there, that's my y-intercept, and it's at -3. So that's going to hit it right here on the y-axis. And so if I look at that y-intercept, I notice like, that coordinate is 0, -3. And so I already have 1 point. And I can figure out the x-intercept either trying to graph it, which I don't recommend because sometimes you don't hit the x-axis perfectly. But let's see. So we can use the slope here to try to see how far it stretches. So the slope is 2. So remember, if your slope is 2, you can always write it over 1 because any number can be written over 1. So this is your rise. So you're going to be going up 2 over 1. Up 2 over 1. And then if we connect the dots here, you only need 2 dots to make a line, but you can do more, as many as you want. But I notice it doesn't hit it perfectly. I think it hits it at 1/2. But just to be sure, another way you can find x-intercepts, if you remember in one of our journals, is you can plug in 0 for y. And so if you were to do this, you'd just plug in this 0 into this equation and solve out for your x. So this would be 0 equals 2x minus 3. And so if I were to solve for x, I would have to add 3 to both sides. This would give me 3 equals 2x. Divide over 2. So that would cancel. And so x equals 3 over 2. Or you can say that that would be 1.5 if you were to divide 3 over 2. So in this case, it does hit it at 3 over 2. And our picture does do a good job showing that, but it's better to actually calculate it by plugging in 0 for y, so that way you can get the exact answer. So this would be 3 over 2 for my x-intercept. And make sure you're writing x and y-intercepts as a coordinate. I want to see them as a coordinate, or else you'll get a half a point off for not showing that. All right, our last final problem here, we're going to be looking at, again, another slope-intercept form. Our slope here is a -3. And so we can say that our slope is -3 over 1. And our intercept is at +4. Oops. So that's our y-intercept. +4, or coordinate at 0, 4. And then for our slope, we can use that to help us draw the graph. So this says down 3. So our slope is down 3 over 1. Down 3 over 1, plot. And again, this one doesn't hit the x-axis perfectly. It kind of hits it between two numbers. So I think it could have been 1/2, but I'm not sure. So let's see by plugging in 0 for y. So we can always plug in 0 for y to find the x-intercept. So if I subtract 4, that cancels. -3x equals -4. If I divide by -3 to cancel that, that means x equals 4 over 3. And so that would have been a little bit harder to guess that that would have hit 4 over 3, which is about like 1.33. So that one I definitely would do by hand, where you're plugging in 0 for y and solving it out. Alrighty there. So that is it for the review. I hope this helped. Make sure you look at most of the problems on the review, or at least each type, so that way you know what concepts that we'll be hitting on the quiz. Alright, if you have any questions, guys, feel free to email me or let me know in class. Bye, guys.